Okay, so we're going to do some power series. The way you can recognize a power series is that they have this basic form here of some x to a power and other stuff according or linked to it. And what you're going to do is you're going to use the ratio test to solve them. And you will end up usually with, after you do the limit, an answer that looks like this. And you will use the conditions of the ratio test to determine the x values in which the original power series converges. So we know the ratio test will converge if it's what? Your answer to your limit is?
It's less than 1.
Less than 1. Good. All right, so what we're looking at here is the radius in the center. If you're taking the limit and you get infinity, then it converges only at the center. Are you writing this stuff down?
Yes.
And the radius is 0. And if the limit is 0, because of the conditions of ratio test, it converges everywhere, and the radius is infinite. Do you understand so far?
Yeah. So if the limit, if any time the limit equals 0, then it's convergent everywhere?
Mm-hmm.
Okay.
Isn't that what ratio test says? Absolutely convergent if less than 0? Or less than 1, sorry.
The ratio test?
Mm-hmm.
Absolutely convergent?
Isn't that what it says?
Yes.
All right, so let's look at one in action. Tanya, I want you to set up the ratio test here.
Okay. Well, the ratio test is an plus 1 over an.
What are you forgetting?
Absolute value.
And
Limit as n approaches 0.
approaches what?
Infinity. Sorry.
You're just testing me, huh?
Yes.
And what do you get on top?
On top you get x n plus 1 over n plus 1 multiplied by n over x to the n.
What do I do now?
You can cancel out the x to the n, and you're only left with an x to the 1 on top.
Okay, and then?
And then and since you don't know if x is positive or negative, it has to stay within the absolute value.
Good.
But n over n plus 1 can be removed.
Okay. What do I do about that limit?
The limit?
Mm-hmm.
You can just divide by n, or you can do L'Hopital's.
First, you need to write down what?
Well, the limit goes to 1.
Because that goes to 0. You're right. And then we're left with the absolute value of x. What do we do with that?
You have to since it has to converge when it's less than 1. You have to set the absolute less than 1, and then get the other bound, which is -1. Replace it, and those become your interval of convergence.
Now what do we do? Are we done?
No. Then you have to test the endpoints, right?
Mm-hmm. So you plug it back into your original, your x value. What kind of series is this?
That is an alternating series.
Alternating series. So what do we do with this alternating series?
For an alternating series, you have to do bn plus 1 has to be less than bn.
I like to do the other one first. What's the other condition? The reason I
The
like
other
to do
condition, the limit has to equal 0.
good. The reason why I like to do the other condition first is because if this one fails, you don't have to do the second one.
Oh, okay.
All right. So
All right.
0.
Yes.
Okay. And then how do we prove it's decreasing?
You can take the derivative.
Okay. So if I look at the derivative, it would be negative 1 over x squared. Is that always less than 0 for x greater than 0?
Yes.
So therefore, f of x is less than 0. Therefore, f prime of x. Therefore, decreasing. You could have also compared the two. You could have said which one of these is bigger. Sorry. Which one of these is bigger?
N plus 1.
That's for all n element of the natural numbers. And then when you take the reciprocal of both sides, which one's bigger?
1 over n.
So you've also proven it's decreasing. Oops, that's supposed to be element of the natural numbers. Okay, either way, it's passed both tests of AST. Used to be for AST, you would have to prove absolute convergence, right? But not when you're testing, not when you're doing your testing of endpoints. If it passes both these, we're good enough to go. All right, because this one would actually be conditionally convergent, right? Because it's
Yes, I
a
do.
P series underneath. Do you understand what I mean? If you were to drop that, that's okay. So if I plug in a 1 over n, I get 1 over n, or plug in a 1, I get 1 over n. What kind of series is that?
That's 1 over n. That's a harmonic series divergent.
Harmonic is not enough. You have to say harmonic what?
A harmonic P series.
And then you get a parentheses for that one. So it goes bracket, parentheses. Got it? All right, let's look at another one.